be explaining how to delete a node from a singly linked list at a given position. In order to understand this, let's take an example. So consider that we have this linked list present and we want to delete the node present at position 3. Head will point to the initial node. So after deleting this node, this is how the final linked list will look like. 1 will point to 2 and 2 will point to 4 as 3 has been deleted. So in order to do that, we need to keep a track of two things. We need to keep a track of the node previous to the node to be deleted, and we need to keep a track of the node next to the node to be deleted. So I'll elaborate on this. So I'll try to explain this within pseudocode. So we have this function present here, delete node. This contains two parameters. One is the head, which points to the head node, the initial node, and the second is the position of the node to be deleted. So if the head is null, let's say it's an empty list, then we will simply return. Otherwise, we will have one more pointer, previous, called as pre over here, which will point to the head itself. The purpose of this will be, it will either be pointing to head or it will be pointing to the node previous to the node to be deleted. So if the position is 1, so that means that we want to delete the head node, and we have made an assumption over here that the indexing starts at 1. So in this case, we will be shifting the head node by 1 using this line, head equals head dot next. We will be freeing the previous, which refers to the older head, and then we'll simply return. So if we don't want to delete the head node, then we'll come to this for loop. What this for loop does is that it will keep moving the previous forward till the time we reach the position previous to the position of the node to be deleted, and in the meanwhile we also have to make sure that the pre will never become null. So the pre keeps moving forward. Once that is done, if after exiting this for loop we realize that the pre has become null, which means that there is no other node remaining, and if the node next to the pre is also null, since as I mentioned earlier, pre stores the address of the node previous to the node to be deleted, which means the next previous dot next, the actual node which we had to delete, is null. So we don't have to do anything because pre has reached the end of the linked list. If that is not the case, then we'll store another pointer next, which will store the address of the node next to the node to be deleted, and we will be freeing up previous dot next, which will be the actual node to be deleted, and previous dot next will finally refer to the capital next with a capital N. So let me try and explain this by doing a dry run on this example here. So initially the head is 1. So as you can see that a head is not equal null, so we will not be returning it, and pre will also point to this. And if the position is 1, so as you can see that the position is not 1 here because we have the position as 3. So we'll be moving forward to the for loop. So the I equals 1 and previous is not null, and I and 1 is less than position minus 1. Position is 3, so position minus 1 will be 2. So we'll be reaching here, and previous will move from here to here. Once this is done, we realize that I will become 2 and position minus 1 is also 2. And that means that we'll be exiting this for loop. Now coming to this condition, so previous is not null and previous dot next is also not null. So now we'll be storing the next pointer. So next pointer will be previous dot next, which means that 4 will be the next. Now we'll be deleting this node, so we'll be freeing up previous dot next, and we will be creating a chain from previous to the next one. So in the last line, this is what we are doing. We are creating a link between these two, and once that is done, we can simply return. So this is how we delete a node from a linked list at a given position. Thank you. Discussing the time and the space complexity of this pseudocode. So Regarding the time complexity, let's in the worst case or the average case, we'll be moving through the entire linked list once. So that means that the time complexity will be O of n, where n refers to the number of nodes present in the linked list. Coming to the space complexity, we are not occupying any additional space. That's why the space complexity will be O of 1. Thank you.